Well, hi all, and welcome to Speed and Security, Reducing the Noise in AppSec Testing. Today's awesome webinar is sponsored by Synopsys and produced by Actual Tech Media. My name is Jess Steinbach with Actual Tech Media, and I'm absolutely thrilled to be your moderator for this discussion. The conversation we're here to participate in today is so important because no matter what our industry is, there is a constant and growing need to add or update security solutions and strategies, which for a lot of us means an increase in tools, data, people, alerts, alarms, just more of everything. And it can be hard to prioritize where and how to start so that you don't spread yourself and your resources too thin. Today, we're joined by Adrian Acuna, Senior Manager, Sales Engineer at Synopsys. Adrian is going to talk to us about AppSec and especially ASOC, Application Security Orchestration Correlation, and how you can start to reduce the noise and increase your efficiency. Now, I don't know about you guys, but I am pretty much on the edge of my seat, so I'm going to zip through a few important points and get us on our way as quickly as possible. First, I want to draw your attention to the questions section of your webinar console. Now, the absolute best part of a webinar like this is the chance to ask questions directly of experts like Adrian. And with something as fascinating as ASOC, I know you will all be bursting with questions, so make sure to get those in. And hey, if we are unable to get to your question during the live Q&A, do not worry. The Synopsys team will be following up with you after the event. Quick reminder that the question console is also a great place to say hi, to reach out to the Actual Tech Media team. So if any technical issues do come up during the session, knock on wood, of course, don't forget that a browser refresh will usually get rid of any tech gremlins, but let us know if not. Okay, skipping along to that handout section, right next to the questions tab in your console. You'll see some exciting content to go along with the webinar today, including a free ebook, Transforming AppSec, the top free ways to build security into DevOps, plus a report on modern approaches to DevSecOps. You can also book a demo and lots more. So be sure to explore that handout section. And hey, it's not just awesome content that we're giving away today. We also have a $300 Amazon gift card as a prize drawing at the end of our webinar. Of course, you must be in attendance during the live event to qualify for the prize, and all winners must meet the Actual Tech Media prize terms and conditions. If you're not sure what those T's and C's are, you can find them again. Just go back to that handouts tab, click in, and scroll all the way down to the bottom. Now, I know with a crew like this, we don't need any extra nudging to ask questions today, but hey, we like curiosity, so we will also be giving away a $50 Amazon gift card to the best question asked during the webinar. Keep in mind that the team will be reviewing all questions asked after the event, which means that even if your question does not get read out in our live Q&A, there is still a chance to win. And as always, we will follow up with you after the event. Okay, team, now I know that you are just as impatient as I am, so let's dive right in. I am so excited to introduce Adrian Acuna, Senior Manager, Sales Engineer at Synopsys. Adrian, thank you so much for being here today. The platform is all yours.
Thank you very much, Jess. I appreciate the attendance and good to meet everybody. Hopefully this will be an informative session for everyone. I'm going to take a minute here and share my screen, so just give me one moment while I get that started. All right, Jess, can you confirm that my screen is being shared appropriately?
I can see it, Adrian.
Perfect. Thank you very much. Okay, well, just go ahead and jump right in. My name is Adrian Acuna. I'm as Jess said, the Senior Manager Sales Engineer here at Synopsys for North America. I'm primarily focused as a subject matter expert in Codex, which is the ASOC platform that is provided by Synopsys. So I'm going to go over a couple things in terms of the platform with the application and the system. So from an agenda perspective, I will cover, let me get this going here, it's stuck in the slide. I'm going to cover what ASOC is specifically and what it isn't, some of the challenges that we try and attack from an application security perspective, and we'll jump into a demo, right? And we'll go into Q&A about the application itself, right? So that's generally what I'm going to cover today. So let's get started. The first thing is, what is ASOC, right? Where does this come from? What does this term mean? ASOC specifically stands for Application Security Orchestration and Correlation, right? This is a term that was jumped up by Gartner. I'm sure everybody here is familiar with Gartner. And where that came from was a hype cycle back in 2019. There is a little section here. I'll highlight it here for you. It's application security, orchestration, and correlation. And this is a new platform that started being introduced or taking trending in the application security space around managing all different application security tools and correlating that information and orchestrating it as well. It continued into 2021, and it's still in period. We'll find out later this 2022 if it's still around. But essentially, it's on this downward trend. There's different stages in the hype cycle for Gartner. I don't know if you're familiar with that, but essentially, it's gone on a downward trend where saying, hey, some of these tools aren't really providing the resources or the expectation that was kind of sold to them. Thankfully, that means a lot of the bad ones are going away, but the good ones like Codex and Synopsys are persisting and only getting better. Along with that, there's another introduction of a concept called policy as code, and you may have heard of that. And that is also a feature of the ASOC platform provided by Synopsys. But I don't want to get too far ahead of that. I'm just going to give you a sense of what we're doing. Let's go back to what is really qualifies as an ASOC tool. And so the main three things: the first, it must integrate with a wide range of commercial AppSec tools. That is a must for any ASOC platform. You may hear some that are out there that don't really have any integrations, or have some we have to write them all custom. But the big thing is they have to be able to integrate with just about anyone out there. But not only integrate that data, but also correlate that data, right? Just bring that data together and figure out where those overlaps are. And it must be able to orchestrate or essentially run those tools centrally from that platform. Those are the three main criteria of what Gartner kind of puts forth for that. So when it comes to what we're trying to accomplish with an ASOC platform, is really the problem is that AppSec can't really keep up with all the different testing activities, all the tools out there. If we look at, or the research study on the clients that we have, ask them like, what is their biggest challenges? And really it's a lack of automated testing, inconsistent approach from where we're bringing all these different results in from, and then trying to figure out how to get through that data as quick as possible, because developers don't really want to wait. They're going to release insecure software, which ultimately can result in a data breach, right? And that's we don't really want any of that, obviously. When we ask a lot of our clients and a lot of our respondents, they generally said they use, on average, for the most part, about 11 to 20 different tools. And that's a lot of tools. And when you start thinking about what those tools are, it's not just a static analyzer or an SCA tool, or just some pen testing. You're looking at crowdfunding information, you're looking at black box, you're looking at fuzz testing, you maybe look at API testing, right? These are all different ways to test data, or just some manual result that somebody came across while looking at the application. So these are all different types of results and testing that occur that people don't always think about when they're doing their testing. And which this results in two main problems. One is pipeline congestion and findings management, right? So essentially it's activity overload from all the different data coming in, and then all the data, how do you manage that data? More tools means more testing, which means more findings, right? So what is the real finding, or what is the data you really want to look at? And that's kind of the big challenge that we want to try and tackle with an ASOC platform. So when we start looking at what the benefits of an ASOC platform is, it's really, first of all, it's a big system of record. It should be a big system of record where you can always go back and look historically from any application of the types of vulnerabilities found, maybe the tools that discovered that specific tool or that finding or that issue. When was that first identified? Maybe a description of that information, who was cited, who fixed it, and maybe a common information. So being able to see and go back historically the trending information of where you're working and how those findings were found and how to address them and how they were addressed, if they were addressed at all. Maybe they were marked as mitigated, right? So this is kind of a big key thing that an ASOC platform should be able to deliver. And I mentioned training, but also tracking that remediation itself, right? When something gets fixed, where did it get fixed at? Which tool was used to fix it? Was it put in a Jira ticket? Was it put in an Azure DevOps ticket, right? So where was that? And then was that essentially managed to get updated status on those specific tickets, and maintain an audit log of that tracking information? Now, additionally, we want to try and standardize the application security tasks, right? So which scanners are being used, right? And maybe centralize that activity, run the right tools at the right level, at the right versions, verify that they were in fact run, and for specific policies, whether it's an internal policy, whether you want to make sure you're always complied by OWASP Top 10 or ASVS or PCI compliance or HIPAA compliance. These are things that you want to be able to attack, and an ASOC platform should be able to handle those kind of scenarios. A single pane of glass from how you're performing, some trending information. Are you getting better? Are you getting worse? Do you have more vulnerabilities being created, or are you getting less? What types of vulnerabilities are more persistent or more numerous inside of your applications or your projects or your teams, for example. So being able to have that, again, is another big benefit of an ASOC platform. And ultimately, you get a unified score, right? So you want to see across all the different testing metrics, what does it look like? If I have mostly custom code or mostly component, infrastructure data, how do you want to score that information? How do you want to view it? How do you want to grade it, right? So this is another key metric. Speaking of metrics, you have other information about, the creation of resolve, delta information. What is your runtime as far as remediating vulnerabilities from critical to highs and mediums? These are all questions that people ask, right? So this is something we want to try and attack and provide by using a platform like an ASOC platform from Synopsys. So when it comes to Synopsys, we recognize that these are all big challenges. These are all things that people want to do. And that automation is really key to enabling a good DevSecOps program. In most organizations, we see the security team, oftentimes they're trying to go to every single tool to get the results from all these different tools. And this is usually a manual process. Sometimes they may have some sort of script that tries to pull it together, but ultimately they may not have a centralized ASOC platform to deliver it all to. Or for them, it may be some open source tool, or maybe something as simple as Excel, that they just put all the data out and they try and put it into Excel and figure out where the real findings are and what's actually correlated, what's deduplicated, if they even go as far as deduplicating it. In the end, they still have to figure out what's a real vulnerability, and that may take up to 10 minutes per finding, right? So trying to filter out all the false positives, maybe filter out all the informational. We only want to look at criticals or highs or something like that. So they're trying to filter all that out first and then say, okay, of these criticals and highs and mediums, which of these are actually real, which can be exploited, right? And so they'll have to mark those. At that point, they have to figure out how to get it into a developer's hands. And oftentimes it means that they have to manually go put that information into Jira or Azure DevOps or ServiceNow, right? So this is, again, a manual effort. And so we're trying to eliminate all these different steps by streamlining that entire activity here into a single platform like CodeX. So CodeX is specifically purpose-built ASOC platform. It has the most integrated tools out of the box. So we support actually over 107 tools today. It says 90 plus. We're currently today we're at 107, meaning that we're constantly adding new tools to the platform. We just added Rapid7 inside AppSec to it, for example. That's coming out today. So there's constantly new information or new data points being brought in. Now, when we say we support the tools, we mean one of two things. We either can ingest the output file from those tools. So some tools like Burp Suite Pro have an XML that comes out, or Web Inspect Standard has a XML that comes out, or we can tie into their APIs. So Burp Suite Enterprise, for example, the API. Black Duck has APIs. Coverity, all the Synopsys tools obviously are supported as an integrated platform, but we can bring in that data on a scheduled basis at an automated pace into CodeX. And that means either on a clock time, or it means as part of a development pipeline build. So as you're scanning information through your pipeline, you want to tell Codex, hey, go pull the results now. We can do that. And we'll talk a little bit more about that in a minute. Now, one thing to keep in mind is that, yeah, we support all these different tools. Oh, sorry. The second way we bring it either, or the second challenge, or the third challenge we have with this rather, is that we oftentimes come across a tool that we don't support, right? There's always some new fancy tool out there. There's probably a new tool every week that we hear about. And it's like, hey, can you support XYZ tool? Well, we may not have native support for it, but Codex does have a SDK that you can build a custom file reader, or you can simply transform that data into standardized Codex XML format, where we can ingest data from any tool out there, whether it's manual pen test results from your security team, third-party bug crowd tools, test results, or just some new fancy scanner that you're using, or a custom-built scanner even that you may be using, can be brought into Codex. So any data you want to put into Codex can certainly be brought into Codex. One of the things we do when we bring that data in, though, is not just aggregate it, which many tools maybe say, hey, we can pump data into our tool. Yeah, we can ingest it. But what are they doing with it? Are they just having a single funnel for that, just put it into one view? Or are they aggregating that data? Because that's one thing that we do at Codex, is be able to correlate and aggregate that data together so we can figure out where tools overlap. So correlation is a big component to any ASOC platform. It's application security, orchestration, and correlation, not just aggregation, right? So when we correlate that data, we can say, hey, from a static to dynamic perspective, where does that overlap exist? Or from an IaaS perspective to a static perspective, where does that overlap exist? You may have different SCA tools that may be reporting the findings, and we want to figure out where those, or maybe different static tools reporting the findings. We want to figure out where that overlap is. So being able to correlate the data to reduce the total amount of noise and really give you a single finding when you look at the data. We can also orchestrate those scans directly through Codex. So if you have some scanners that you wanted to trigger through Codex, maybe you want to build it as part of your pipeline build and have Codex run the scans instead of having to have every single scanner be part of every single build cycle. You just have Codex as part of the build cycle and tell Codex to run those scans to centralize, again, the proper scans are being run, the right versions at the right rules. You can also, if you want to ad hoc you run a scan, you don't have to wait for a pipeline build. You can just run it through Codex instead of having to go to each independent tool to actually run those scans. So orchestrating those scanners is also a capability. When it comes to the security team, they're going to look at Codex and be able to go to one single platform to then view the results from all the different platforms and in one centralized view. But they still have to figure out what is false positive, right? That legwork hasn't really gone away. So with Codex, we've introduced a triage assistant or a machine learning algorithm that actually learns from the efforts of your triaging team or your development team or your security team. So whenever they mark something as escalated or mitigated or they create a ticket, then we can say, hey, we're learning from this the way behavior that your team is auditing. And then as new findings come in from new projects, we can analyze those findings and say, hey, we're pretty sure, we're 90% sure this needs to be marked as escalated because you've escalated something in a different project that's very similar to it. And we can give you 90% confidence. Not only can we do that, we can automatically create that ticket for you. So if you want to create a ticket in Jira or ADO or ServiceNow, the triage assistant and the policies within Codex can enforce that and automate that whole process. So again, eliminating the need for you to have to go through those extra steps. At the same time, things when something is false positive and comes in and you marked it false positive in the past, we can learn from that, say, hey, these findings look like they're going to be marked as false positive. So we'll make a recommendation. We'll say, hey, we think you should mark these as false positive. Then your team can then target those first to eliminate further noise from all the different tools. So again, giving you a place to start from and reducing the amount of effort your team has to work and be able to work more efficiently and faster. Again, like I said before, we can then put these tickets directly into a ticketing platform like Jira. It could be Azure DevOps or ServiceNow or GitLab. This is the current one to support. If you have an external custom tracker that you want to use, then we can certainly support that as well. We can track the tickets in there as well using a customized setting within Codex. We can always expand this tool as well. So it's completely customizable. That status is bidirectional, and we'll see that in the demo a little bit when we get to it, where we can see the tickets being created and we can see the ticket status being changed over time as something changes. One thing that we do in the Codex as well, we can actually certainly do all the things we just did. We also have capabilities that expand beyond with the rest of the Synopsys tool chain. So there's an intelligent orchestration, which is really about policy as code and codifying the applications as terms of what to scan, when to scan, the continuous scanning intervals to make sure it scans on a regular basis, and make sure certain things are staying within policy. So if you want to make sure that the OWASP top 10 isn't being violated, it can send notifications on, it can integrate with the whole platform. But there's two things it does. It does a pre-scan policy to help you run, not just run tools that Codex does, but also run the right tools. So if nothing from an SCA perspective has, or a open source component perspective has changed, then don't run an SCA scan, right? So, or maybe if not enough code changes has happened in the static side, then don't run a static scan. It can also schedule manual results as well, or manual tests, pen tests as well into another platform. So we have a lot of ways that you can intelligent orchestration to help Codex run, but help it run more efficiently and much more leaner from a pre-scan perspective. And then at the tail end, once things have been completed and all the data has run through Codex, intelligent orchestration is able to then have a post-scan policy to say, hey, this particular application has 3 vulnerabilities that are more than 8 days old, and then send notifications out to Slack, to Teams, or send email notifications, or send alerting to some other tool that you want. So the whole idea of intelligent orchestration is to manage that policy of how you want to make sure things are managed and monitored. Now, I've talked a little bit about the security side and the DevOps side a little bit, but I do want to keep in mind that this is also developer focused, right? We want to make sure the developers have the right information when they need it. So they can always tie into Codex through an IDE plugin, where they can actually view the same data that they would see inside of Codex directly within their plugin, within their IDE. So they can make their comments, they can see the application that they're developing right now, where the vulnerabilities sit in every single file and every line of code. And those will come up as indicators inside of their IDE. So we support Eclipse, Visual Studio, IntelliJ are the three major tools we support today, but it does give you a way to do that. In addition, there's also just-in-time training. So if they want to know what a vulnerability is, there's a video that is provided by Secure Code Warrior to give them that type of insight as well. So again, some additional capabilities that exist from a developer's perspective to give them some capabilities that they can take advantage of within CodeDX. From a DevOps perspective, we do have plugins directly into CI/CD. So again, like I said before, we can trigger and automate and be a quality gatekeeper for code as it comes through to say, hey, you've introduced 2 new critical vulnerabilities. We're going to fail the build. We're going to pass the build. And we have several different CI tools that we support for that function. And then lastly, over time, like I mentioned, it does become a system of record, right? So we can then see over time how you're performing, how you're trending in terms of the vulnerabilities, and we'll see some of that information in the dashboard and the historical information. All right, so that is the presentation side. I want to go ahead and jump into the demo now, and we'll take a look at what Codex offers from a DevOps perspective. So let me pull the demo environment up. Give me 1 second. Okay, so you should be able to see a Codex web interface now. So as I go through here, some things that's key in the Codex is that it has a concept of projects. So in Codex, when we look at these projects view, we have a way to define projects to be either an organization unit, it could be an application, it could be a microservice. But the idea gives it a lot of ways to group and manage and organize the data into different ways. So when we look at the applications, we can say, hey, we have this great view of the Synopsys web applications. Then inside of here, we have different regions that we want to be able to look at. Then each region may have its own set of applications that we want to then manage. So Budget, KaiMonkey, WebGoat, for example, are all applications. When you do that, you can then take advantage of 2 things. One, you can have role-based access control, where users, when they log into Codex, they can only see be restricted to the data that they've been privileged to. So if they only want to see Europe, then they can only see the Europe section. If they only want to see Asia or just one application, for example, they can do that. Or maybe they just want to see the whole Synopsys web applications, or maybe everything. That's up to you. But that's the first thing. And the other thing is we can then view data across the whole platform. So when I look at the Synopsys web applications, the dashboarding within the platform gives me a way to see for all the applications and all the children, I can see that, hey, there's static analysis. We've done cloud infrastructure testing. I can see for each one of these and how we're trending or how we're performing on each particular type of scanning. And I can view it across as a holistic view. I can see the component score and I can see infrastructure score. So when we look at an application, if you're deploying it internally, we can then say, hey, this is the application we're supporting. Maybe it's our bank site, for example. And we can include the host information for those specific services or applications, because it's one thing to keep an application secure, but if the underlying infrastructure is not secured, then that's also a vulnerable point for that application. So if that's taken out, well, then the whole application is gone at that point. So this gives you a much more holistic score in terms of how your application is performing, how it's secured, etc. The other thing that we have is an open findings view, so we can see, the total number of findings and how critical they are. The findings trend count information. We have average days to resolution. If you want to make sure that you are resolving or remediating vulnerabilities in a certain amount of time, we can quickly see that from a dashboard perspective. Some code metrics. What are your applications made up of? Are you running the right tools against those languages? Analysis frequency and activity monitor. This create and resolve view is unique. So when we look at trending, we can see, yeah, we're creating more vulnerabilities, or we're fixing more vulnerabilities. That's one thing. But what is that delta between the creation and the remediation? And that's where this graph is extremely powerful, because we may be going up in vulnerability count. We may be going, we're constantly creating more, but we're fixing more than ever at the same time. So that way it gives some hard, concrete data to say, hey, we are doing the best we can. We're constantly fixing vulnerabilities, and we've gotten this much better at it in the last 30 days. But the development team is continuously still producing more and more vulnerabilities no matter what. And then we can go back and look and see from a top finance perspective, these are the most prominent vulnerabilities that we're seeing, right? Code injection, LDAP injection, or authorization and authentication. So I can say, hey, 30 or 40% of my vulnerabilities, new vulnerabilities, are coming from these types of findings. So can we bring a trainer into the development team to focus on how to quit producing these kinds of findings specifically? So this is an area that you can have hard, concrete data to management to say, hey, this is where I want to focus on. This is how we're performing, and this is how the applications are sitting. And this goes not across just a entire family group. I can look at it on a specific project as well. So I can always go to just one project and see how that particular project is performing. It's in and of itself. So again, just different data points, different ways to view the application. You can also view the findings across all the applications. So if I look across findings, I can view all the projects for all the applications. I can say, all right, I want to view where am I producing a lot of cross-site scripting, for example. And I can go in here, cross-site scripting. I'm going to look across all my applications. It includes all the different tools that maybe run against those applications. And I can then also see which particular family is most prevalent. So I know Synopsys Web Applications is the most prominent. And I can say, well, show me on a flat list, which particular application is it? And I can say it's WebCode. I can see it's the Microsoft or microservices 1 and 2, right? Have the most prominent ones. And I can select those and then view what those findings look like. Which tools were found in it, the detection method that they were found in, whether it's IaaS or DAST, severity of them, and maybe if it's a specific file or location or web interface, I can see that as well in these filters. So again, another way to slice and dice this data, but also strictly report and view across all this different data. Speaking of reports, I can then generate reports on this data as well. So I can quickly go into here, generate a compliance report in terms of DSSDIG, OWASP top 10, PCI or HIPAA. I can just create my own custom report and include specific information about that file, or just output it as a CSV or XML to be ingested into some other platform. And while I'm talking about other platforms, all this information and all the data you see can be scripted and automated and codified again. So if you wanted to build some other third-party tool to pull data out of Codex and report into that, that's perfectly fine. We have a pretty broad API availability. The whole application is API driven. So anything you see in the UI, and whether it's in the metrics or whether it's in the findings, can all be pulled out through an API perspective. So that said, I'm going to jump into one application here called Budget. This Budget application is similar to WebGoat in that it allows you to view data across one application. Rather, it's purposely built vulnerable application that allows you to kind of hack the application and kind of do some training on it. But in this case, I'm going to look at this and we can see that there are 229 findings out of 895 results, right? And so we can see different inputs that exist here, but essentially it's a bunch of different data point that have come in and been brought into this particular application. But this allows us to see that quickly that what we've done is we've deduplicated all these 900 findings or results down to 229 findings, right? So this is a 75% basically reduction in total number of findings. This is based on the data that's come in. So we can quickly see, hey, we want to reduce as much data noise as possible and just give you what the actual total number of findings that exist for your environment or application. In this case, we see that it's a lot of Apache license. I can sort this by the type. So if I'm looking for a specific type, I can do that. I can do any search on that finding as well, whether it's a CVSS scoring or a metadata tag that's coming from a specific tool or finding location. I can view this data across any specific tool type that may have been brought in. So we have all the different tools that are listed and including those rules. So those rules may be operational, the types of codes that may have come in from that tool as well. It does show the age of those findings. So if you're concerned about show me the findings that are more than 7 days old, we can see that as well. And we can filter by criticality, when they were first seen, the last time these findings were modified, maybe the overlap. So if I look at, what tools have overlap with 3 tools or more, or 2 tools or more, or just 1 tool. Another unique thing about Codex is we can view data by standards. So, if you're curious about how you're performing against HIPAA perspective, I can select the HIPAA standard and select that particular filter, and it'll show me specifically that we have 29 findings that are violating HIPAA subpart C, for example. So that is an easy way that we can accomplish some standard management within Codex. We have ASVS4. We have about 29 or 30 different standards that we support out of the box. So whether it's OWASP top 10 or PCI compliance, or CLASP or MITRE, for example, or MISR rather. There's also tags we can support. So if you want to tag any findings with specific data tag information, we can do that. To predict the status, I mentioned before, the triage assistant. So when we look at this data here, we can see that there's a status or a predicted status here of escalated or false positive, for example. So we can say, well, show me things that we think that need to be escalated, and maybe with a 75% confidence, or we'll go here, 70% confidence rate or more. So we can say that we have a couple that we're pretty sure to be escalated. In this case, they've already been escalated. But this will give you a quick way to view data that comes into Codex and say, hey, I want to focus on those first. I'm going to jump into another finding here, that this finding has a bunch of information for different tools. So again, what we want to do is try to reduce the total number of findings that you see by deduplicating the data across multiple tools. So in this case, we have one single finding that's cross-site scripting, and it was found by Coverity, Nessus, Polaris, and Zap. So these particular findings, or these particular tools, all found the same finding. When we look at any individual finding inside of Codex, you have a couple different areas you can modify. You have a status, if you want to set a specific status for that finding. We have a description. What was that finding about? In this case, it was stored cross-site scripting or DOM-based cross-site scripting. We have details, information about that. Some guidance about how to remediate it. Now, we have a training video that shows specifically how to remediate that finding. So here you can view directly within the UI, what causes cross-site scripting, what are the potential ways it can be exploited and how can it be used and violated, and then how to fix it, right? And how to remediate that particular vulnerability and why it's important. So these are videos that can be seen in the UI itself. It can also be delivered as part of any ticket. So if a developer wants to come in and view it, they can actually view this video as well. Standards violations, again, all the different standards that this particular finding might violate. And then the evidence, where data is used to support this particular finding. So here we have evidence from Zap found it from a dynamic perspective, Nessus found it from a network analysis perspective, and then Coverity and Polaris found it from static analysis, right? It scanned out the source code and said, hey, this is what it looks like. But inside here, we keep as much data as possible from those tools. So we have, the contextual description, we have the activity from the request, the response. If you want to look at the actual data, the raw data that came back from the request side or the response side, we will show that way. We're keeping as much data as possible from the scan. So again, trying to centralize all the data from all the different tools into one view. So you don't have to go to every single tool independently. We can view that information directly out of Codex. When it comes to like static analysis, we can show the finding information, we'll show the description from that tool, even maybe a callback to the tool itself. So if you wanted to have a link back to the actual tool, yeah, we can provide that link back to the tool if you need to. We'll show data flow. We can quickly see from the data flow, where was it found, and then the next stage as it was going from source to sync all the way through will be visible here. So you can see that source code directly inside of Codex. You don't have to, again, go back to the tool or open up an IDE to see that. And we'll show it on both sides. So depending on the tool that may have found it, it may have found a different data flow itself. This example where Polaris found it a little bit differently from Coverity. This information, again, is all available inside of Codex by pulling data in. So how do we get this data into Codex? Right? So there's a couple different ways. The first way is through, let me clear this filter here, is through what are called tool connectors. So tool connectors, like I mentioned before, are where we use the tool's APIs to actually connect into those particular tools. So we have about 30 or 40 different tool connectors that we support today, or maybe 30 connectors that we support today, where we can just pull that data in and actually connect to the APIs and bring that data in on a scheduled basis or an automated fashion, or maybe as part of a regular analysis, right? So if I look at this Coverity one, we have the information about the UI, the username, the select particular project that you want to pull in, and then if you want to adjust all components, etc. For the Black Duck one, we can also get a little more specific about including the security risk, or maybe the operational risk, or maybe only import data that's maybe medium or higher, for example. We can also set that setting within the connector. So a bunch of different ways to actually bring that data in that way. The other way is to upload it through an analysis, right? So when I go to analyze, I can add files to be ingested into Codex. whether it's like a web inspect file or a burp suite file or a zap file, we can add that file by clicking add file, and we can upload the file directly. We also have a capability within Codex to orchestrate scans. So there are a couple bundle tools that exist inside of Codex that are part of it or bundled with it, where we can actually analyze source code content, and based on the source code content, we can make a determination, say, oh, we see some CSS source, some Java source, some XML. We're going to go ahead and run these specific tools that are configured to run with Codex, with check styles, PMD. And we could have run spot bugs or dependency check. These are particularly disabled right now on this particular environment. But if I had configured Coverity or Black Duck, I could run those as well through Codex directly through this orchestration platform. So we can run those tools right out of Codex. Once the analysis is completed, we'll automatically ingest the data from those specific tools and results into Codex. So again, we can centralize either through uploading the files, through the connectors, or by running them directly out of Codex itself. So that's how we get data into Codex individually. But once it's in there, then we can deduplicate it and correlate that data altogether. So when we correlate data, we look at the location and the type. Location comes from the tool. The types are defined within Codex, though. So location may be, search.jsp, it may be a line of code. But when the Codex, we can normalize that location by using hybrid analysis mapping. So for some frameworks like JSP, for example, we can tell that this endpoint, this file will generate the endpoint search.jsp. Because of that, we can then say, oh, we can map it to this zap finding because we know it's the same location. We can also tell that from the source code itself that it was using parameter Q, right? So we can see that here, parameter Q is being used. And because in this zap finding, it also used parameter Q as part of the query, we know that it's going to overlap for that location. So we know the location is the same based on that technology of hybrid analysis. But then there's a type, right? So this is a lot of tools out there that do correlation will typically just go off of the CWE. So we can see from the CWE perspective, do they match? In this case, we see CWE 79 here. This also says CWE 79, and this says CWE 79. So that's all well and good. But what if the tool is different, right? What if it's CWE 87? Well, it's a little bit different. So that's not the same CWE, but we're still going to group it because Codex has its own system for building a rule configuration. So you can actually set up Codex to say, hey, for cross-site scripting within Codex, I want to make sure that I want to define cross-site scripting as CWE 79, right? I wanted to say that. But if I see any other tool result coming in with any other of these CWEs, then go ahead and group it together as cross-site scripting, right? We want to kind of group as much data as possible together. So when a tool comes in with CWE 84, or I think it was 87, I'm not sure which one it was, but when we see that, we can automatically still group it under the same type. So these types of rules is what gives Codex a leg up against other tools and platforms out there. It's a way to customize the correlation engine itself. So no other tool gives that type of level of correlation where we can group these types of rules together. If a tool doesn't provide a CWE, right, that's common. Maybe pen testers don't always provide a CWE. That's fine. They'll usually provide some sort of code information. So we can add in a specific tool type and code to say, hey, if we see this tool category or this tool code, we're going to bring it in and we're going to group that also with cross-site scripting. So again, another way to group data together consistently. So this is another powerful feature of Codex, is being able to customize how things are correlated and deduplicated across the platform. All right, so I dug into that a little bit about all of this in Codex. I'm going to jump to now, how do we get this data? So we know we have a finding, we've said, hey, we're going to need to get this fixed. Let's put it into Jira, for example. So we can take this finding here, for example, and I'm going to create a ticket inside of Jira. So within Codex, I have an issue to create, or an ability to create an issue here, and I can say bug, and I can put whatever information I want in this. But you can see it's already populated with some information, right? So detected by Black Duck. Here's a link to the finding within Codex. There's the file and the line number, or the component rather. Information about if there's a training video, there'll be a training video. But we also bring in any custom fields that might exist inside a ticketing system. So in my Jira instance, I have a custom field for security tools used. So I want to set that information up. I have information about security status reviews. So I can say, if it's in review, etc. I can set those status as well. And I can hit OK. and then it'll create the ticket inside of Jira. So how did that information get populated? Right? So if I go back to the application, my mouse is stuck here. There we go. Go to the application here. I can look at the issue tracker configuration, and we can see that there is a customizable template system called handlebars, where we can use this information to actually configure and programmatically set what that description is going to be. But it gives you a lot of capability to put a lot of logic around when something is going to be created and what information is going to go into that ticket. So this could be, maybe you want to put the tool description into here, or maybe some sort of metadata from those tools. We can add all the information directly into the platform using this type of templating. We can also map stuff information, so when something changes inside of the Jira or the ticketing system, we can update it within CodeDX, or vice versa. When something changes in CodeDX, we can go update it in the ticket. So maybe a developer fixed it, but never closed the ticket. So next time you scan, we see that it gets marked as gone. We can automatically go update the ticket inside of the Jira ticketing system, or vice versa. Maybe they've closed it in CodeDX, but when you scan it again, we still see it, so that we can reopen that ticket. So different ways we can modify that. And we can automatically create tickets as new scans come in to begin with. You can set up rules to say, hey, assign it to CodeDX, assign it to specific users, maybe group it by location or by type or by severity, maybe by CWE. You can ways to group all that data. We can do it for only criticals, or maybe only if it's 4 tools or more are found it, etc. And maybe only do it if the triage assistant actually found it. Like I said before, we can set it if it's found at 80% or 90% or higher, then create the ticket, because it's pretty high confidence, so it's probably right. So you can set those kind of standards up. You can also configure it to be respective of OWASP. Maybe if something comes up against OWASP ASVS version 4, then we can say, hey, go ahead and update it because this version has been updated, and we need to make sure that we don't violate that particular development standard. So that's a way section to see that data and modify and support that ticket. So if I go into this particular ticket within Jira, we can see my Jira instance has it marked as to do. If I go and update to done, for example, I can refresh this and it'll be marked as done, right? So we can have that bidirectional status change within CodeDX. So different ways, again, to manage and track that data as we're moving along the development pipeline. This also can be part of the pipeline itself. So when something, as your build cycle goes through and your something runs complete, all your scans complete, you can then tell it to go to CodeDX, find all the aggregated and deduplicated data, bring it back. If there's a new critical finding that's been found, we can pass or fail that build. So a number of different ways to actually use CodeDX to streamline that process. All right. So at this point, we have about 15 minutes left. I'm going to turn it back and actually do some presentations and questioning, see if there's anything that we can address.
That was awesome, Adrian. Thank you so much. What a wonderful presentation. And that demo is incredible.
Thanks. Thank you.
Well, we have a ton of great questions coming in. And actually I want to start with this one right off the top, because I think it's a great place to kind of start our discussion. Are you ready to jump in, Adrian?
I'm ready. Yep, whenever ready.
Okay. Bradford is asking, do you consider Synopsys a DevOps tool, a SecOps tool, DevSecOps? Where do you typically see Synopsys in organizations?
Yeah, that's a good question. So CodeX initially started off as a SecOps tool, to be fair, right? It was really a tool that was meant for the application security teams to kind of manage all the data coming in from all the different tools, and that was it. But over time, it has graduated to more DevSecOps, where more of the development team have taken advantage of. They wanted to see, hey, there's a lot of tools that have to be run, a lot of scanners have to be run. How can I centralize this, or do I even want to manage it on a DevOps side? Can we push this more to security and just work with them more in tangent with each other instead of being opposing forces? And so we've repositioned a lot more to be more interactive with the development team and the DevOps team and the DevSecOps teams. I would say it starts oftentimes as security, and then it kind of rolls into DevSecOps as it continues.
Awesome. I love that. And we'll have a follow-up question from Bradford as well. He's wondering if all the tools that you displayed as connected are included with the product, or do you have to separately purchase analysis tools?
Yeah, that's a good question. So there are bundle tools that exist within Codex that are open source tools, like dependency check, for example. Those are included as far as the Codex platform. But Codex is tool agnostic. We don't care what tools you use. And it was really purposely built for customers that typically already have a wide array of commercial tools out there. They may already have Coverity or Black Duck or Checkmarks or some other tool out there. And they want to be able to centralize the management of those data. We've had clients that have multiple of different types, different tools of the same type. So they may have Coverity and Checkmarks because they've bought another company or acquired another company that has their own security team. And so they want to bring in those tools. So when it comes to the commercial third-party tools out there, those are separately licensed, whether it's a Synopsys tool like Coverity or Black Duck, or whether it's some other tool. But there are some tools that are included as part of Codex, but those are open source tools. Now, that said, you can always expand what Codex is running. So we've had clients that only want to run open source tools. And so they'll get Codex and then they'll create their own runners to run through containers to actually run other scans through Codex that don't require licenses, for example, but they do have to be run and set up separately. So hopefully that answers the question. The short answer is if it's a commercial tool, it's your own license you have to get. Codex comes with open source tools that are included with the platform.
Well, this will fit in well with that then. We have someone wondering, so if there's all these different tools coming in, it's hard to quality control. So if there are deficiencies in some of the tools that an organization is using, is that going to impact the results of an ASOC?
So I guess the way that follow up, it's when you say deficiencies in terms of what goes into Codex, yeah, it's garbage in, garbage out, right? So Codex is going to expect the tool to have some sort of information that's hopefully decent. But if junk data goes in there, then yeah, it'll certainly impact how well it is. But that's also where the auditing team comes into play and says, hey, we're going to bring the data in, but the auditing team has to ultimately say whether something needs to be marked as false positive or something needs to be marked as escalated, and really triage that data, because there is no perfect tool, right? If there's one perfect tool, then there would be no other tool but that tool. So, yeah. Okay.
Okay. Well, let's talk about the type of company and size of company that can benefit from a tool like this. So smaller teams without a lot of support versus big teams with complicated infrastructures. Is this going to work for everybody?
So there's a purpose, I think, for every client out there. We have had clients that are just small, 5-10 person dev shops, and they are using it. They use primarily the open source tools that exist in Codex, right? Because they may not have the budget for a large commercial tool, but they're satisfied with the tool that they want to run, or they'll just add in their own custom tools. Or because we support so many tools in general, they'll have other analysis coming in from different tools. We also work with rather large clients. I mean, Codex started off in the government space, so it's been primarily focused initially for the first 2 years within the government. Now, you would think the government's a huge company. They have massive development teams. They really don't. They're really actually very much siloed. So it's really a lot of small dev teams that are using Codex. They spin up a project, manage the vulnerabilities, create a report, and they close it out and go on to the next project. That's generally how they operate in the government side. And they're all very secret. They don't always all work together. I mean, they may be under one umbrella, but they're all individual. Now, that said, we also have very large organizations where they have thousands of applications that have Codex, and they're just trying to manage all the data coming in from all their different tools and see across the application portfolio what's vulnerable and that status of those applications. So it can work for everybody. I think the biggest things we look for when we target, or not supposed to target a client, but when we start asking a client or they're interested in a platform like this, what does your workflow look like? That's a real bigger question. What does your workflow look like from an application development standpoint? From when you first decide, I want to build an application, are you doing threat modeling on that application? Because if so, where do you put that threat model data? Are you putting it into any particular place? Are you doing any development analysis of it before you decide, like Security Compass, for example, has a platform where it can say, hey, you're going to build this application with these types of variables. You're going to be potentially vulnerable to these type of vulnerabilities. Are you going to capture that data? That's another source, right? And then from the design perspective and actually generate the application to write it out, what does that work look like? How are you going to bring the data in? Where are you going to manage that data? Are you going to manage? Are you going to put it in Excel? Because that was the example we used in the presentation. Not always the best place to do it. It's a place, but it's not always the best. And then from there, how are you going to create tickets? Are you going to manage those tickets and the tracking of those tickets? So it's not just the size of the company. It's not just the application. This how complex is your workflow, and how are you going to manage it? And does this seem like something that's going to benefit your workflow? Because we're more of a workflow management than just a security tool itself. Is what we see it.
And it sounds like there is a lot of opportunity to set those the prioritization, to kind of set up your own rules. I think you mentioned policy as code. Do you want to dig into that a little bit more?
Yeah, there's certainly policies code in Codex where we can set up the pre-scan policy and the post-scan policy within the platform, or the Synopsys platform overall, to say, hey, we want to make sure that we're always abiding by PSAC compliance and send alerts and notifications that if not, or at least be able to view that report or generate a report to an auditor, right? So these are all, again, workflows, tasks, things that have to, action items that have to occur. And so that's where we kind of take Codex and say, this is where it can really fit into those organizations.
Perfect. Okay. We have somebody wondering, so if this is in the pipeline, in a developer's pipeline, am I asking my developers to become security experts? I know you mentioned, so they get the little notification saying, oh, there's a vulnerability here. Is there a clear flow of, if you see this, then this is your action step, so that the developers don't have to think about what comes next?
Yeah, so most developers that interact with it typically work through Jira. So whatever's in Jira is what they will want to work on first, or whatever ticketing system they may use, whether it's ADO or Jira or GitLab. And then from there, they have an assignment of tickets that they can go and tack inside of Codex. Now, they may use the plugin, so those flags only show up in the source code in their IDE if they use the plugin for Codex. Otherwise, they may not. And inside the Jira ticket is usually all the detailed information that they would need to remediate it. So they would say, this is what the vulnerability is, this is how you can remediate it, and that's coming from whatever tool or whatever description exists inside of Codex. So we'll provide some information as part of our description, but oftentimes tools have more specific and maybe even code snippets as part of the description that we can actually include in the ticket as well. So it's really up to you. As far as the IDE plugin and showing up the little flags, if they have that turned on, that's really not so much to make the developer a security expert. We recognize that'll probably never happen, right? But it is a nicety to say, hey, as you're going through the code, if you see this critical, if you're already in this file, then you can maybe go to manager. Hey, I'm in the code right here. There's a critical finding here. Do you want me to address it because I'm right here anyway? I have to work on this piece of code or this line as it is, and they can get approval to go from that perspective. And at that point, they can always go into Codex and view the finding data. And again, from their IDE, they can quickly see the description of the finding, the evidence, all the details that came in from that tool, maybe the data flow that existed for that, and why it's important. So it's not so much to make them security experts; it's just to give them the benefit of being able to go beyond the next step they wanted to do, right? Go above and beyond, I guess I should say. So.
That's awesome. Man, I wish we could keep chatting, Adrian, but we are getting very close to the end of time. So I'm just going to ask a few more questions here. One, I love when this comes in. What has you personally excited in AppSec and specifically at Synopsys these days? What are you pumped up about?
So, that's a good question. So I committed to Synopsys as part of CodeX, and CodeX is a smaller company, and so we were acquired by Synopsys a little over a year ago. And since been at Synopsys is, if you're not familiar, Synopsys is the leading in application security, like the Magic Quadrant. You see that? Synopsys all the way up to the right. And we've been constantly growing. We have a wide array of tools. And we're not shy about getting new tools. We just recently acquired White Hat Security. So from that perspective, we're improving it and up at the game there. That is a excellent platform, an excellent company. So we're constantly growing, and I'm happy to see and looking forward to where Synopsys goes next. We're definitely pushing the boundaries on what's capable and what can be available to the AppSec community.
That's awesome. Okay, so if for everyone out there that has just completely fallen in love with Synopsys and is ready to learn a little bit more, what do they do next? How do they get started here, Adrian?
Certainly go to the website. We can get started information there. There's a few links in our what's it called? The documents here that you can actually request demo information and go from there. We can certainly set up in time, but certainly reach out to our team and our website to figure out where we can go from there. That's the most common way.
That is awesome. And yeah, just that reminder, as Adrian was just saying, if you visit the handouts tab, there's some links there, and one of those is to book a demo. So definitely worth checking out. Adrian, as I said, I wish we could keep going. We are totally out of time, but thank you so much for coming in for this presentation, the demo, and the discussion. It's been an absolute pleasure.
Great. Thank you very much. Thank you, everybody, for joining. Appreciate the time.
Okay. Well, that was awesome. I don't know about you guys, but my brain is still reeling, and I think we should keep this excitement going. So we are going to give away a $300 Amazon gift card. The winner of that prize today is Todd Corey from Texas. Congratulations to Todd. As always, we will be in touch about claiming your prize after the event. And with that, on behalf of the Actual Tech Media team, I want to thank Synopsys for making this event possible, and just a giant thank you to Adrian for an absolutely fascinating conversation today. And hey, sending high fives and special thank yous to all of you for attending and asking some awesome questions. These events are so wonderful to be a part of because they give us the opportunity to connect with each other, with these experts, and explore innovative new ideas together. I know that I have learned a ton from this discussion. I hope that you all have as well. I can't wait to see you all at a live event again soon. And until then, I hope you have an absolutely beautiful rest of your day.